Hi everybody, this is Mrs. Dinkelman, and these are the notes for lesson 1.3, infinite limits and limits ad infinity. These are our vertical and horizontal asymptotes, just written as limit statements using calculus. So this review at the beginning here is a lot about what you did in pre-calc, and we've talked about it a little bit. So remember, if we're able to cancel, then we know that there's a hole in the graph. We're going to talk about this even versus odd. It can be helpful. It's not absolutely necessary though. So there's definitely asymptotes at x equals 2 and x equals 4 because we weren't able to cancel those away. The x equals 2 is an even asymptote because of the exponent there is an even. And at x equals 4, we have an odd asymptote because the exponent is odd there. Now, what that tells us, if it's an even vertical asymptote, it's going to be one of these two things happening. So both of the asymptotes either head up toward positive infinity or both are at negative, as opposed to odd, they're going to go in opposite directions. So that can be helpful because if you know what's happening on one side and you know what's an odd asymptote, then you know what's happening on the other. And same with even if you're trying to find that. So these at first don't talk about horizontal asymptotes. That's really like the second half of the notes. And I'm going to go ahead and do the video for both parts, but if you only get half of it done today, that's kind of okay. So these are the ones we're used to. Remember I told you that if we write equals does not exist here for infinity and negative infinity, that is totally acceptable on the AP exam. For this particular lesson, Gary would really like you to think about whether we're doing positive versus negative infinity. That way, if we're graphing, we have the ability to draw that. So we're going to walk through deciding whether it's a positive or negative infinity here. And notice with all of these, like, okay, we're approaching 2. That's 0 in the denominator. That's definitely an asymptote because remember, if it's a number over 0, that's going to be an asymptote. If it's 0 over 0, then we should be able to do some algebra like we did in 1.2. I'm just going to quickly inspect here and say, just make sure they're all asymptotes. Just in my mind, checking if they're a number over 0 or if they're 0 over 0. So this one looks like a 0 over 0. Remember, Gary likes to throw those tricks at us. So let's go ahead and do this one by factoring. This is one like 1.2. Again, anytime you get 0 over 0, there's something we can do to be able to find our limit, okay? So don't forget to look for those as well. All right, let's go back to these other ones. So I definitely know all of these are does not exist ones because there's a 0 in the denominator. But now, again, today we just want to make sure we can decide whether it is a positive versus negative infinity. So what I like to do, again, knowing it's some sort of infinity, is plug in a number really close to 2, but on the positive side of 2 in this case. So I'm kind of thinking of 2.001, and I just want to decide whether this is going to be a positive versus a negative. So positive on the top, positive on the bottom, so this is going to be a positive infinity. This one we could check, and we will in a second, but I'm going to tell you that this is an odd asymptote because this would be to the first power. And so I automatically know that they're going to do the opposite things on either side. Again, look back up at the picture with odd asymptotes. If you don't remember that, just plug in something close to 2, but on the negative or left side of 2. Oops, I need to plug in my number there. So it'd be a positive on the top, but a negative on the bottom. So that's another way to decide it's negative infinity. Okay, so same thing here. Let's plug in something that's close to 1, but a little bit bigger than 1. Oops, I forgot my -2. So that would be a negative on the top, but a positive on the bottom. So this should be negative infinity. And this is an even asymptote. So when we look down here at example 4, we know that these two should do the same thing. So this one should be negative infinity. But if we forget and we just want to double check, we would plug something from the left side of 1. So maybe like 0.999, however many you want to do there. Okay, so this is going to be a negative on the top, but a positive on the bottom because it's squared. So that's another way to see that you would get negative infinity. So if you want to right now, those are those vertical asymptotes just written with limits. That's the only difference. So you want to pause the video and maybe go try those particular type. So that's 1 and 2, and then 7 through 16. And then if you have time and want to come back and watch the rest of the video, then you can. Okay, so second part here, these are the horizontal asymptotes. And you might have talked in pre-calc about top heavy, bottom heavy, and equal. And so top heavy, if you just want a quick reminder, I don't know that you really talked a lot about top heavy, but if you end up with a top heavy, then that's going to be no asymptote because it would technically be infinity. So think the top is really huge and the bottom is pretty small, so you're still going to get a really huge result. Bottom heavy, we got 0 for our asymptote, and that's because think about you have something pretty small on the top, but you divide by something really big, that number is going to be pretty small, and it's going to head towards 0. And if the degrees are equal, then we look at the ratio of the coefficients, and that is something you're probably used to. So for instance, this 6, 7, 8, in pre-calc you might have said, okay, number 6, this is equal because it's equal degrees, and so we would have a horizontal asymptote at y equals 1/2 because that's the ratio of those coefficients. Number 7 is bottom heavy because that degree is a little bit higher on the bottom, so our horizontal asymptote is at 0. And on 8, it's top heavy, which means technically this means there's a slant asymptote, which we won't talk about a lot. I think you did that in pre-calc. We're just going to say that this doesn't have a horizontal asymptote because it's top heavy. Well, those really are limit statements. That's what we're really doing. So if you look at 9, it matches up to 6. So as x approaches infinity, we get that 1/2. On 10, it's a little bit, I guess it's not really different. It does have a negative infinity here, which we really should be, and I didn't, checking if there's a difference between when I plug in an infinity or a positive or negative. Because there are some graphs that will have like a horizontal asymptote that's different depending on which direction we're going, okay? Luckily, it doesn't matter here because this was to the 4th, and 0 and -0 don't make a difference. Here, same thing, it's bottom heavy, so we get 0, and it doesn't matter that that's a negative, but sometimes it does. And this one is top heavy, so I would get infinity. Remember, does not exist is also a perfectly acceptable answer. And then we just have to be careful because sometimes they want to trick us a little bit. So I believe this is a 3rd degree on the top, and my brain is kind of seeing that if we multiplied it out, it would be a 2x cubed on the top. Again, I'm just worried about, there's kind of like a plus blah, blah, blah here. And on the bottom, if I multiplied it out, there'd be a 9x cubed plus blah, blah, blah. So they are equal, and the ratio would be 2/9. So this limit should be 2/9. Again, that means that this has a horizontal asymptote at y equals 2/9. There are a couple that are a little bit more challenging. So our square roots can be challenging, and that's because we didn't spend a lot of time in algebra class talking about when you square root x squared, you actually get the absolute value of x. We should always get a positive out of just a random square root, that not when we're solving, because when we square root something, we put a plus or minus, but if the problem just already has a square root in it, we should always be getting a positive out of it. So this particular number 13, if I tried to simplify it, so I'm going to ignore the -3 because subtracting 3 once you have something that's infinite doesn't really do anything. So that really simplifies down to the absolute value of 2x over x. If I try to plug infinity in there, it is going to be an infinity over infinity. They are the same degree, and it is a positive over a positive. So that would just be 2. It's different in this case, though. Still simplifies down. But when I plug in a negative infinity up here, the absolute value would turn it to a positive, and the bottom would still be a negative. And so that would make this a -2. This is one of those graphs like up here where it has a different asymptote on either side of the kind of infinity versus negative infinity. Some of these, just kind of remembering what e to the x looks like. So quick reminder, e to the x looks like this. And so at negative infinity, it is heading toward the y-coordinate 0. Positive infinity, this thing just keeps going on as I get bigger. This one we want to kind of think of in two parts. So e to the negative infinity, again, negative infinity, I know that's a positive, but that makes it a negative in my brain, is 0. And then this part is equal. Degrees are the same, so it's the ratio. And so we get 2. And then we don't see these very often, but I have an acronym that helps me decide what goes faster, what's bigger. And it's NN-FEPL. These first two we don't see a lot, but this would be if we had an x in the base and the exponent. F is for factorial, so like an x factorial. We don't see those very often. This one is for exponential, and e to the x is probably the most famous one. P is a polynomial, so anything that's just x to the something. And then logs, and this grows fastest to slowest. And that can sometimes help us determine whether something is top-heavy, bottom-heavy, or equal. So if we look at this problem, we have a polynomial on the top, and on the bottom, we have an exponential plus a little bit more. So the polynomial fits here, and the exponential is here. The exponential grows faster, which means this guy is bottom-heavy. Now, just by the way, top-heavy, bottom-heavy, equal, those are not like formal definitions or ways that we would justify. We just need to know the answer. So you don't need to say it's 0 because it's bottom heavy, but obviously if you're thinking bottom heavy in your mind and then you have the answer, that's totally fine. So again, because the exponential grows faster than the polynomial, this is bottom heavy and we get 0. Okay, you should be able to do the rest of the assignment. Don't forget to look at, there were some cut out. I don't know if those numbers are the same that were on your answer or your assignment sheet, but probably pretty close. And I will see you all Friday.